The potential link between the Y chromosome and autism risk. Autism spectrum disorder, ASD, is a complex neurodevelopmental condition characterized by a range of challenges related to social interactions, communication, and behavioral patterns. Understanding the causes of autism remains a pivotal area of research, and recent studies exploring the role of genetic factors, specifically the Y chromosome, have opened up a new line of inquiry that warrants a detailed examination. At its core, autism is believed to have a strong genetic component. Studies indicate that individuals with a family history of autism are at a higher risk of developing the disorder, suggesting that genes play a crucial role in its etiology. Researchers have identified numerous genetic variants associated with ASD, but the intricate interplay between these genes and environmental factors is still not fully understood. The Y chromosome, one of the two sex chromosomes, is unique. Typically, it is associated with male characteristics, as males have one X and one Y chromosome, XY. Females possess two X chromosomes, XX. The Y chromosome contains a relatively small number of genes, but many of these are critically involved in determining male sex and in spermatogenesis. Its influence on other biological processes, including neurodevelopment, has been less explored, but findings from recent research suggest that it may have implications for autism risk. One key hypothesis that has emerged is that variations or deletions in genes on the Y chromosome may be linked to an increased risk of autism in males. A significant body of evidence suggests that autism is more prevalent in males than females, with estimates indicating that boys are 4 times more likely to be diagnosed with ASD. This disparity has prompted researchers to look for potential explanations, including genetic differences that may be specifically associated with the Y chromosome. Recent studies have indicated that certain genetic variations, particularly those involving the Y chromosome's role in neurodevelopment, could contribute to this gender disparity. For instance, researchers have noted an association between abnormalities in the Y chromosome and a range of neurodevelopmental issues. Specifically, genes like SRY, region Y, and other Y-linked genes might play a role in brain development. Research has also focused on Y chromosome microdeletions, which are small deletions of genetic material on the Y chromosome. Some studies suggest that these microdeletions could lead to an increased risk of neurodevelopmental disorders, including autism. This connection may be attributed to the loss of critical genes necessary for normal brain function and development. Furthermore, researchers have postulated that variations in Y-linked genes might impact processes such as cell signaling, neural connectivity, and the regulation of neurotransmitters, all of which are vital for typical brain function. Inconsistencies in these processes may manifest as the behavioral and cognitive traits associated with autism. It is essential to approach the relationship between the Y chromosome and autism risk within the broader context of epigenetics and environmental interactions. While genetic predispositions can increase the likelihood of autism, external factors, such as prenatal exposure to toxins, maternal infections, or even lifestyle choices, can interact with these genetic factors and influence neurodevelopment. The concept of epigenetics underscores how environmental exposures can lead to changes in gene expression without altering the DNA sequence itself. This means that even if an individual carries genetic risk factors associated with the Y chromosome, environmental factors could either exacerbate or mitigate that risk. The potential link between the Y chromosome and autism risk is an exciting area for further investigation. Understanding the mechanisms through which specific Y-linked genes may influence neurodevelopment could provide insights into both the biological underpinnings of autism and the development of targeted interventions. Future studies must aim to unravel the complexities of the genetic landscape of autism, including the roles played by the Y chromosome and its interaction with other genetic and environmental risk factors. By employing larger cohorts, advanced genomic technologies, and interdisciplinary approaches, researchers can build a more comprehensive understanding of how these factors contribute to autism. In summary, while the connection between the Y chromosome and autism risk is still in the early stages of exploration, The findings thus far suggest a compelling avenue for further research. Given the higher prevalence of autism in males, understanding how genetic factors, particularly those related to the Y chromosome, influence this disparity is crucial for developing more effective diagnostic and therapeutic strategies.